Hello everybody, this is Mohammed from the InLab Study Group and CEREC On Demand. Many thanks for Sirona for having me here today to talk about in-house model milling. I'll be going through a quick presentation for the accessories and instruments needed for milling models in-house. Then we'll do a software presentation. After that we'll go through some of my cases and I'll be taking questions by the end of this webinar. When I receive a Sirona Connect case, I have the options of milling the restorations modelless, or I can order an SLA model through Infinident, or I can mill the models in-house. To mill the models in-house, you would need the InLab software, accessories and instruments, and the InLab MCXL. Now only the InLab MCXL machines starting with the serial number 120,000 or higher are able to mill models. If you have an older machine, you need to upgrade that machine to mill models. The picture here shows the motors that are able to mill models. Milling the models with older motors or with diamond burrs will void your warranty. You will also need the tungsten carbide Shaper 25 and finisher 10 burrs. They're only designed to mill the in-chorus model blocks and you can't mill any other material with them. Also keep in mind that the Shaper 25 has to be inserted into burr set 2, which is the step and point 12S burrs, while the finisher 10 has to be inserted into burr set 1, which is the step and point burr 20. You will also need burr change instrument and torque key. Both of them are already part of the InLab MCXL pack list. If you have an older machine and if you don't have either, I strongly recommend acquiring these two instruments because they will prevent you from over tightening your screws, and that will definitely stop a lot of issues and problems with your milling. You can also need the milling chamber, screen, and residue. Milling models results a fibrous residue that will be in the milling chamber. All you need to do is just take it by hand and throw it away. What I do, I use a trick. I always pretend to be very busy, and I ask the lab driver, not the InLab driver. I ask the lab driver to clean the machine for me, and it always works. So you can give it a try and let someone else do the job for you. Also, you're going to need the in-chorus
You will also need
model S and the in-chorus model L.
and finisher 10
Both of
burrs.
them can only be milled with the Shaper 25 and the
They're only
finisher
designed to mill
10.
the in-chorus model blocks, and you can't mill any other
Also
material
model
with
base
them.
plates. There's the
Also
quadrant
keep in mind
and the
that
full arch.
Shaper 25
Also the
has
same
to be
thing for
inserted
articulators.
into
There's the
burr set
quadrant
2, which is
and
the step
full
and
arch.
point 12S
And
burrs,
you will need
while
the
finisher
model
10
pins. All components are
inserted
fully
into
compatible
burr set 1,
with
which
Sirona
is the
Connect
step
SLA
and
models.
point burr 20.
The pinning tool. With the pinning tool, the pins can be pressed into the middle segments. With the movable arm, the segments can be pushed out again, and there's an additional functionality for it by pushing out segments from the model base plates. Those pictures show how you can use the pinning tool. Sirona provides a starter kit. You can start by these, or you can buy all the accessories according to your preferences. Milling strategy. It starts with parallel roughing with the Shaper 25, drilling the pinholes with the finisher 10. Then there is a selective finishing process from 3 angles with the finisher 10, also milling the anterior undercuts, then trimming the segments with the finisher 10. Then you break out the model segments, you do the pinning, you place the models in the base plates, and then you have the option to articulate it with the Serona articulators, or you can use your own articulator. We're going to go through that later on. Now the presentation is done, and now I'm going to go on and start doing a software presentation. Okay, so now we get to use the software. I'm going to start with the example connect case that comes with the software. Now when I receive a Serona connect case, I start by defining the restorations. Then I have the option of defining the model now, or I can just proceed with my restorations, and while they're being milled, I can go back, design my model. After my restorations are being milled, I can crystallize them, center them, or polish them while my model's being milled. Either way, you need to start with your restorations because you need to edit the model before you mark your margins. Then you mark your margins if you want to ditch your dies. So if you want to start by milling your model, you need to correct anything that needs to be corrected in the digital impression, then mark the margins, otherwise you won't be able to ditch the dies. Also, it's very important to edit the model before you mark the margins. For example, anything that I'm gonna do here on this die using any of these tools will remove those margins. Now going back to the model, click on the model. I'm gonna skip the edit model and set model axis to the model orientation window. Here you can define where you're gonna place your models on the base plates. The left click would rotate them, while the right click would place them in any direction, move them in any direction you want. Now looking at the left side of the window here, the right model will move your models vertically, and by doing so it would not affect your vertical dimension because it's already been preserved by the articulating pins. It's very simple and straightforward. Now, before I go to talk about segmentation, I want to talk about model parameters. When I got my software, I kept them as they are, and I milled the model because that's the best way to determine your parameters or adjust your parameters. Your first mill, or at least your first 3 mills, they will help you determine what are the right parameters for you. I kept them all as they are. The only thing that I changed was the pin diameter. When I measured the actual pin diameter, it was 1.95, so I took this down to 1.92, and they just clicked in and they were perfect. When I milled them at the I think they were like 2.04, they were loose. The rest remained the same, and I didn't adjust anything with it. The base plate distance, it doesn't change. Actually, it doesn't change your base plate distance. What it does, it is adjust the height of your models. Now I'll go to the segmentation. If you open your segmentation window and you find that 1/3, 2/3, or half of your model is in red, don't worry about that. Anything in red means that it's not going to be milled. So before you do the segmentation, your software doesn't know that you're going to mill that model into pieces. The software considers that arch is going to be milled after one block. Segmenting is really easy. It's just like you're using a virtual saw cut. You double click one click, single click, and then you finish it by a double click. And there you go. You go down and then you choose your upper. Now we're going to go to the ditching. To ditch a die, you just simply double click the top of each die and the software will ditch it for you. Margins will be preserved because you already marked them while you were working on your restorations. So when you mill your restorations and you go to your milled model, margins should be perfect. What I like about the inlay 4, it's easy, straightforward. Now, model pinning, there's the automatic and the manual. Now, when it's in pink, that means you can't pin them, and the moment you place them back on the base plates, they're gonna be pinned here. Each die needs 2 pins. If the width wasn't enough for 2 pins and you only need 1, just make sure, like it's one of the dies here in the middle, because 1 pin is not good enough. If it's on the one here at the beginning, it will be rotated. The manual is really easy. You just double click and place as many pins as you like. Usually 2 are enough. Let's go to the other here. Okay. It won't allow you to proceed unless your pinning is perfect. Unless if you go to the manual, and then it's up to you. But the software will not let you go without 2 pins in each die. Now it's calculating the milling preview, but we're not done because we still have a few steps to go through. So that's how your model is gonna look like. Then you need to export to the stack software. Now the stack software, you need to start with new stack. To always start with this number, you can just put model. And then you choose the block. It's Sirona in course model. And then you need to collect them. Now that's a lot because you're doing a full arch upper and lower. Usually it's like less than that. You just simply click and it shows you here which part of the model you're getting into the stack software. Click on the arrow here to proceed, and then you need to double click while the software calculates the stack position. Now that's the milling preview of the stack software. I'm just double checking everything is okay here. Now this computer is not attached to a milling machine. When I choose my milling, I can click on start milling here. Now milling time. Usually if I'm milling a small quadrant, it might take 25 to 35 minutes. If you're milling like a case like that, would take about 75 to 85 minutes.
I would like to share a video from InLab by Sirona YouTube channel about in-house model milling.
Here we have an actual Sirona Connect case. The dentist called me Thursday late afternoon, asking me if I can deliver 4 anterior PFMs before Friday noon. So I told him maybe in a parallel universe I would have the powers to do that. While I was talking to him, I double checked the impression and I told him it's perfect for Emacs. He agreed to that, but he insisted on having models articulated so that he would check the case before he delivers it to the patient. The dentist was leaving on a 2 weeks vacation and he had some anxiety about this case. I told him, well, it's not a big deal because I can mill the models in-house, and that impressed him a lot when he knew the quality and the variety of the service that I can provide with the system that I have. So I designed and milled the crowns and I gave them to the ceramist to be crystallized, and I went back to the administration tab. It was a straightforward, easy case thanks to the software. Here we have the upper. Dies being ditched. Now, I made a mistake here with the pinning. I thought having one pin in each die would save me some time. The upper and lower will melt in less than 35 minutes, and I don't have any issue with the dies here, but my issue was with the cuspids. They were rotating, and I could have simply, with the handpiece, create an extra hole and inserted one of the pins. But why should I do that while I can do everything digital? So I strongly recommend having everything in blue and the pins in green. That's the milling preview. It's a small case, really nice case. I'll be showing you pictures of that case in a few moments. That was the first model I ever milled. I forgot to add the second prep tooth here while I was on the stack software. So what I did, I used the remaining part of the block to mill that tooth. Here in this case, I had a TZI crown. I wasn't sure about the contacts, so I milled a solid model to double check the contacts before I send the case out to the dentist. I had a lot of remaining here in this block, so what you can easily do, you break this part, then you level it with the trimmer. You have your block, and I used it to mill another solid model for a TZI lower anterior bridge to check the contacts. Usually I don't do that, but in some cases I'm not so sure about the impression, or I have some doubts, so I mill a solid model and check my contacts. Here's the case where we did 4 anterior Emax crowns. I did 1 hole instead of 2 for the pinning. So that's the final product. Dentist was very impressed that we milled models in addition to all the materials we have. Here in this case, I did 6 lower anterior TZI crowns. I wanted to compare the milled models with the SLA in terms of accuracy. So I milled a solid model here, and I milled single dies ditched to check the margins, and the case was identical in both models. Here we have an adapting plate with a magnet. You can use that for full arch cases or big cases where you would need an average or semi-adjustable or fully adjustable articulator. You can just simply place the base plate on that and articulate it with, it has magnets, or you can just simply articulate the plates using plaster. Here I have another Sirona Connect case, 6 anterior Emax crowns. One of the things, now I have the margins marked. If I go back to edit model, and I use the remove tool. Now if I'm gonna mill a solid model to check the contacts, I would have to use the handpiece to trim the gingiva. Why do that while you can do that virtually? So what I do, I use the remove tool to virtually remove all that gingiva here that would interfere with the crowns. And you can go with the smooth tool. Now as you can see, the area here where I adjusted the model, I lost the margins that I marked. So that's why at the beginning of the webinar I told you, like, it's very important to adjust the model or do any editing in the model before you mark your margins. Generally speaking, like when I do that, I do that in a same thing like when we pour a second pour to check the contact. I export the file and I do that in an individual folder. Also, you want to make sure your solid model would fit in the block. So you can do that for the rest, and you would have a solid model that you don't need to touch or adjust anything with it, and it's ready to be used for checking your contacts. Okay, so now I get to answer some of your questions. First question here. Is the upgrade for the older MCXL available? Yes, the upgrade has been available since the in-house model has been released. Now, if you purchase a new in-lab MCXL, it would come already with the in-house model milling feature. You don't have to upgrade it. Okay, now another question here. Do I have to order the starter kit, or can I order the individual parts and blocks. This is totally up to you. What I did, I went through the what's the package of the starter kit, the price, also what the individual parts and blocks that I need to buy, and also the price. I found the ordering individual parts served the lab needs. On the other hand, the starter kit price would be less than like 50% if you buy everything individually. I know a lot of labs who started with the starter kit. In our case, we just went with the with buying everything individual. Okay. My model pieces, another question, my model pieces do not fit together. It appears the sockets are too tight. How can I adjust this? Well, that's easy. You just need to go to the model parameters, and you need to adjust the segmentation cut width. And after the milling, check the model. If it's still too big, you need just to lower it down. That goes for anything you mill. If there's you can adjust everything with the parameters according to your milling results. Another question here about I get low water pressure error after you mill the models. Okay, every time I mill models, I get a low water pressure error on the next case. What happened to all the liquid? Well, when you use the milling for a long time, not just with models, that would reduce the machine heats up, and that reduces the some of the water evaporates, and that reduces the water level. The sensors in the machine are very accurate, and the moment the water level or the filters get dirty, they will get an error. What you need to do is I would take the water tank out. I make sure that the tank is not too dirty, because the you get the error message for both. And I would just top up the water tank. Also, when you insert a new tank, some of that water fill out the pipes, and that reduces the water level. After a few mils, you would get the message of lower water level. You just need to top up the water. Now, speaking of water, I use 100 ml of dentate oil per tank. I think the tank takes 2 liters of water. If you want to try and add more, it won't harm. Adding more oil would never harm your mill. It's having less oil. So I know a lot of labs who tried the 100 ml, and they're still using the 100 ml. Excuse me. And it works perfectly. So that would be it. Okay, another question here. That's a good question. Can I wax the milled models? Now, milled models are as accurate as the SLA models. That's my findings. And yes, you can wax them, but now the question should be, would you wax, like when you receive a digital impression and your work is all digital, why would you wax the model? Simply by waxing the case, you're creating a margin of error. The idea of digital dentistry is accuracy. So what I do when I receive digital cases, digital impressions, I mill the coping out of AcryCAD or CAD wax or in-course wax to eliminate any margin of error, because all these materials are made of acrylic. There won't be any dimensional changes. I don't have to worry about any discrepancies in this material. So why would I wax a digital impression? But each lab has their own techniques, and I totally respect that. But most of the CAD/CAM labs that I know, they went from waxing the cases to milling their coping and frameworks out of acrylic. Okay, that's a question that I get a lot. What is the cost per model? I really don't know the actual cost per model, but what I know is that no matter what the cost is, which is not big, it's less than pouring the model, pouring an actual impression, because here the labs in Ottawa, it would cost us a minimum of $10 just to get the impression here. I didn't pay that because we got we got that digital, and then you have to pay for materials and to pay the wage, the labor for someone to pour that impression and to cut and trim and ditch the dies. All that you can do that digitally. So I know even the SLA models, the cost for us here for a Canadian lab, a lab here in Ottawa, it's less than having someone here to pour them and cut them and trim them, and the cost per to pick up. So the cost is minimal, and you can reuse the base plates, you can reuse the articulators if you like, if you wish, if you have access to that. Okay, I think that would be it. I'm not receiving any more questions. So before I finish, I would like to thank Sirona for having me here today to talk about in-house model milling. It was an honor. I would like to remind you of the CEREC 27.5 on the 16th to the 18th of August. Also, you can check inlab10.com for details about InLab 10th anniversary and the free tuition for lab technicians. Today's webinar will be broadcasted at inlabevents.com. You need to scroll down and you'll find all the other webinars there. Thanks for having me here today, and we'll see you soon. Thank you.